Okay, so in our previous lecture, we have gone through some details of we saw some theoretical concept related to the labels, how the labels are distributed and how the traffic flows. Now let's see a quick practical of it. So we have the same example. We have four routers and we are running EIGRP between R1, R2, R3 and R4. So I'm at R1. Let's say if I do a show IP route, so I am receiving the 14 network, right? I go to R4. So R4 is sending this 14 loop back into AIGRP. I'm at R4. If I do a show IP interface brief, so we have this IP 14.1.1. If I go to R1, if I do a ping 14.1.1, I'm able to ping, right? So connectivity is fine. EIGRP is running perfectly. Now also do a trace route. So the trace route is going like this. It is going to R2, then R3 and R4. It's a simple path. There is no complexity in that, right? It's a flat path R1, R2, R3 and R4. Now let's enable MPLS between all these devices. I'm at R1. So the interface is serial 3 by 0. As I discussed in my previous lecture, it is very simple to enable MPLS. So for MPLS, one thing that we need to make sure is Ceph must be enabled on all the devices. If if Ceph is not enabled, MPLS is not going to work. So that you need to be very sure. So I'm at R1 and the interface is serial 3 by 0. So interface serial 3 by 0. I just need to give one command MPLS IP. That's it. I'll go to R2. R2 is having two interface 3 by 0 and 3 by 1. So I will go to is serial 3 by 0 MPLS IP and serial 3 by 1 MPLS IP. You can see as soon as we enabled MPLS on 3 by 0, the LDP neighborship is up now, right? Because LDP is running. We enabled MPLS and now LDP is into action. The neighborship is also up. Show MPLS LDP neighbor. You can also check for the LDP neighborship. So with this command show MPLS LDP neighbor, you can see the 20.1.1, the neighbor is up, right? Address bound to peer LDP identifier is 20.1.1.1. So now let's enable MPLS on R3 as well. So R3 is having two interfaces, S3 by 1 and serial 3 by 2. Serial 3 by 1 MPLS IP and serial 3 by 2 MPLS IP. You can see between R3 and R2 LDP is also up now. I will go to R4. R4 is serial 3 by 2 interface serial 3 by 2 MPLS IP. Now let's verify a few things that we earlier discussed. On R1, this is the connected subnet, right? 20 networks. So in the local table of R1, right, the label for 20 network must be the implicit null, right? For 20 network, the label that R1 will generate is implicit null. So if I do a show MPLS LDP bindings maybe, right? So you can see for the 20 network, the local binding or the local label which is created by R1 is implicit null. And in our MPLS header lesson, we discussed that the code for MPLS header, the label number 3 is known as the implicit null, but you will not see this value if you are going to check any bindings or something. So you will only see implicit null. So you will not see, okay, this is label number 3. No, you'll only see this value. Okay, so let's verify a few more things. So R2, let me check one more thing. So for 20 network, you can see here the remote binding, right? The label is implicit null. So R, because for R2 also the 20 network is locally or the directly connected network. So for R2 also the 20 network is directly connected. So it will also generate the local label as implicit null. Likewise, if I go to R4, so for 40 network, because it is the loopback and the 40 network, it will generate the implicit null label. This information I can check at R3 if I do a show mpls LDP forwarding table, or simply I will say show mpls forwarding table. So this is the lfib that we discussed in our previous lecture, right? So if you check here, uh, the only network in the lfib is 14 and 20, this network and this network, because for R3 this 30 network is directly connected. So as we discussed in our previous lecture, in the lfib there will not be any entry for the connected network because it is not required, right? So now let me ask you a question. If I do a trace route from R4 to this interface of R1, in the trace route, in the trace route path, how many mpls label we are going to see? Now let's find out. If I do a trace route, I'm at R4, I'm doing a trace to this IP 20.1.1. So we saw only one mpls label information, right? Only R3 is generating this information in the trace route. Why it happened is because let's say I'm at R4, right? R4 is going to check its lfib. It find out that okay, in my lfib, if I need to go to the 20 network, I need to use which label? What is my outgoing label for that? It is 17, right? And what is the exit interface? Serial 3 by 2. So R4 will create a packet and the outgoing label will be 17. Now the information will reach to R3. Now R3 will check its forwarding table, right? For 20 network, what it needs to do? It needs to pop it. So when, because R2 is going to remove the label, so R2 is not going to receive a packet with at the MPLS enabled interface which is having the label, right? Because R3 already popped it out, and R2 is receiving it as a normal traffic without the label. That is why if you see the trace route here, only R3 in the path of R3 we can see this MPLS label, right? Because after that R2 is receiving this information without label. That is why you are not able to see any MPLS in this trace route. What if we do a trace route from R1? Then how many labels we are going to see if I do a trace route for 14.1.1.1? Now you can, I think you already get the idea how many MPLS keyword we are going to see if we do a trace route from R1 to the loopback of R4. Let's find out. If I do a trace route 14.1.1, which is the loopback here, right? Now here you can see, now we are able to see two labels, right? Why we are able to see two labels is R1 is going to check its lfib. In the lfib, it's find out, okay, for 14.1.1, the 14 network, my outgoing label is 16. right? My exit interface is this. So R1 is going to give R2 label number 16. Okay, R2 will check its forwarding table, show mpls forwarding table. So R1 sends which label 16. So now for 16, what is the outgoing label for R2? For R2 also it is outgoing label is 16. Okay, now you can see here or it is clear that the labels are locally significant, right? Because two different devices can generate the same label number for the same network, right? So R2 is also going to swap this its own label with the label number 16. So now if I go here, if I do a trace route, because R2 is also putting one label, right? When we see here, R2 is also going to put label. There is no pop operation here. So R2 is going to send to R3 label number 16. That is why in the trace route, you can see we have the MPLS information here, label number 16. It is going to send to R3. If you see at R3, show MPLS forwarding table. So R3 receives the label number 16, right, from R2. So what is the outgoing label for R3? It is POP. So R3 is going to remove the label, right? So before R3 sends the information to R4, it is going to remove the label. That is why if you check here, R1 receives, and now R2 is going to pop it. Then R4 is going to receive it. Let's say if I'm at R1, do like this, I create one loop back, let's say 10, IP address 1.1.1, 255, okay. Show IP AGRP interfaces. Now if I, earlier when we were doing the trace route, right, from R4 we were able to see only one MPLS information in the trace route. Now if I do a trace to 1.1.1, right, maybe using my source loopback IP. So now you can see, now we are receiving, we can see two labels, right? Because now at R2, this pop operation is going to happen. That is why we are able to see the MPLS information in the trace route at R3 also and at R2 also. That is why now you are able to see the MPLS information at both the devices. So this is the last device which received the MPLS labeled packet, right? After that, the MPLS information is removed, and the next router, which is R1, it is going to receive the packet without any label. That is why, as we discussed on a MPLS enabled interface, if the router receives anything without label, it is going to check its routing table. If it receives something with the label, it is going to check the LFIB. So this is how the normal label operation happens. In our next lecture, we are going to start discussing about the layer 3 VPN. We'll dig into more and more details. So first, I think we are going to discuss in our next lecture regarding the RD value, what is route distinguisher and what is the use, what's the concept behind RD. And then step by step, we are going to start building our MPLS network.